Okay, so your quiz tomorrow over 1.1 through 1.3. If you looked over the what you need to know, the format is 30 questions. Okay, they're mostly short answer. There's a few that are multiple choice, and it's no calculator. And this is like, it's just 30 points. You either are getting it right or getting it wrong. So we got to make sure that we know how to do everything here. So you can see the first thing you need to know is the sets of rational, irrational numbers. And that does correspond to your first question here. So they ask you what are irrational numbers, and then give some examples. Okay? Do you guys have questions for me on the definition? Maybe we just went over that. I showed you some possible answers. Are there any questions you guys had? Okay. And then you had to write an example for each of the following. So the commutative property, that's when they are, I like to think of them as symmetric, right? So it doesn't matter if you do x times y squared or y squared times x, those are the same. When you have the associative property, you should have parentheses. So it doesn't matter if you add the first two together first or the last two together. Be able to identify those. And then the distributive property, 3 times x, 3 times 2 is going to be 3x plus 6. Okay, so you can see here it says the property, associative, commutative, distributive, so know how to do that. Alright, and here we have the distributive property. You guys did a nice job with this from what I saw. Remember, if you're multiplying a fraction by a whole number, you multiply by the top, divide by the bottom. So 6 times 5 is 30, 30 divided by 3 is 10, and then because this is a negative times a positive, it'll be negative 10. The x stays with it. A negative times a negative is going to be a plus. Okay, so if you're doing negative 9 times negative 5, 45. 45 divided by 3, 15. Okay, you could also write it out like I did here. Do some simplifying. Really, it's whatever's easier for you for that. Okay, perform the indicated operations. So, if you are trying to simplify a complex fraction, anytime you're adding or subtracting, what do you need? Common denominator. So, 11 times 12 is 132. 12 minus 11 is going to be 1. And then you skip, flip, multiply. Sorry, that's how I was taught. Are you guys keep, change, flip generation? Yeah, keep the first one, flip the second one, change the sign. Okay? And then all you're doing is 132 divided by 6. You could do that old school, but aren't they both even? They're both even. Just divide each of them by what? 2. Okay, so divide by 2, divide by 2. And then all I have to do is divide 66 by 3. How many times does 3 go into 6? 2, so it's 22. Okay? So this part doesn't have to be complicated. Just reduce and then simplify. Okay? The next thing it says is know like your number sense, your inequalities, write algebraic expressions. That's going to be the next few questions. So select the correct statement. So in order to do this for number 5, well, you can kind of see what my strategy was. I wanted to get them so it was a common denominator, so it was easier for me to compare them all. Did you guys do something similar, or what did you do since you can't use your calculator? Okay, so if you have a common denominator, then you'll be able to compare all of them. So it was 14 and 13. So if you just multiply those together, then you have the same denominator. You just have to multiply the top. So 13 times 9 was 117. Okay, 8 times 14 was 112. And then I just compared. Is 117 less than 112? No, so I crossed it off. So I did the same thing here. It's not even like I'm even trying to multiply these two together, because if the bottom's the same, then you only have to worry about comparing the top. And again, this ended up being 9 times 13, so I got negative 117, and then negative 112. Okay, they said negative 117 was bigger. Okay, why is that not true? Because of the negative, yeah, it's further away from 0, is the way you want to think of it. Good. Okay, and then for C, 117 is greater than 112, yes it is. For D, negative 112 is less than negative 117. This is the same thing as this. They were just written in 2 different ways. Okay, and then this is a negative and this is a positive, so I didn't even have to worry about that. A negative is not going to be greater than a positive, so it would be C. Okay, so process of elimination. Alright, I know some of you probably were second guessing yourself for 6 because it just seemed too simple, right? It really is just that. X is greater than or equal to 4. Okay, as an inequality. Alright, now, when you are doing the unions and the intersection, which is the next thing you have to know how to do, okay, know that when you have, like that upside down U, that's the intersection, that means and. So those are the elements that are in both A and B. So the only 2 numbers that are in both are 6 and 10. You can see I've circled them in my work. Okay, and then for the union means or. So that's the elements that are in A or B or both. So you have to have everything in either one. Okay, and then you don't have to repeat. So if it's repeated, you don't have to do that. Okay, for number 8, express in interval notation. So if there's the equal to, how does that translate into the interval? The bracket. Okay, parentheses will be if there's no equal to. So this is interval notation here. Okay? Alright, evaluate this expression. So if you have absolute values inside absolute values, okay, start in the innermost absolute value. So the absolute value of negative 10 is 10, minus absolute value of negative 9 is 9, absolute value of 1 is 1. So 1 is your final answer. Okay? Alright, and then 10, find the distance between the numbers. So this is the formula. You just subtract them and then you take the absolute value. Okay? You could also think of it as counting on a number line. If you were to count on a number line, negative 1 to 0 is 1 unit, 0 to 9, 9 units. 1 plus 9 is 10. Alright, so something we've been working on are our factor trees. So if you have the 4th root of 625, okay, maybe some of you know that off the top of your head, but I would recommend your factor tree. So if it's 625, why would I start with the 5 first? Ends in 5, right? So you can divide. If you need to write it out, you can write it out. So 5 goes into 62, well, 6 1 time, goes into 12 2 times, goes into 25 5 times. So 125 plus you. And then this would be 5 times 25, 5 times 5. The reason why you write it like this is because now, right, you have the 4th root of 5 to the 4th. You can think of it like that because we know the 4th root and the 4th power do what? Yeah, they cancel each other out. They undo one another. Okay, so then this is just 5. That's how you get your whole number of 5. Okay, and then for 12, evaluate the expression. So again, you can see I'm doing these factor trees. Now, every single time you do one of these, the number that you need changes depending on the index number. Okay? I think I did 15. Yeah, I did the 10 first instead of the choose. Did you guys do choose or the 10? What did you guys do? Did you do the choose right away? Okay, so half of 150 is 75. What do you know? What's a prime number that goes into 75? 5 times what? Please don't guess. Just if we're not sure, then let's do this out. 50 times 4 is 60, right? 60 plus that?
That was my first answer.
It was?
Yes.
Okay, and then here you have 2, 5, 5, 3. Okay? So you can't take anything out yet. That's okay. These are being multiplied. Okay? So we're going to combine them all to one big cube root. Okay? So 180 Again, you can do the 2, leave 2 and 90, 2 and 45, 5 and 9, 3 and 3. It doesn't matter what you do as long as you get there. So I can see with the 2's, how many 2's do I have? Well, that's nice, because those will cancel. Okay, how many 3's do I have? 1, 2, 3. How many 5's do I have? 1, 2, 3. Okay, so what happens is all of these are going to cancel out. You're left with 2 times 3 times 5. So 2 times 3 is 6, 6 times 5 is 30. Okay, that's how you can get it without your calculator. Could you multiply these together and then do it? Yeah, but that's going to be a headache. Okay, keep the numbers small. Alright, for this one, you're evaluating the expression, so you can see I plugged everything in here. This one is nice because what happens when you multiply 7 by negative 12 over 7? When they cancel out, so you have negative 12, okay? So you have negative 8 plus 100 minus 12. It doesn't matter how you do that. I just said, okay, that's 100 minus 20. So now I have the 4th root of 80. If I have the 4th root of 80, now I'm going to simplify. Again, we're going to do that factor tree. So 2 and 40, 2 and 20, 2 and 10, 2 and 5. Okay, how many 2's do I have? Oh, that's nice again. So I have the 4th root of 2 to the 4th times the 4th root of 5. That's by itself, right? Because I have 4 2's and 1 5. So those cancel. That's how you get your final answer. Okay, questions for me on those? Lots of factor tree. Yes, just take the question there. Okay, and then we did 14 together yesterday with the cube root. I know some of you weren't here. This is what I recommend doing, okay? I would start with the smaller one. Let's do the factor tree for 200. So again, cut it in half. Keep cutting it in half until you can't half it anymore, okay? So again, you see how there's 3 2's? So what comes on the outside here? 2. What stays inside? What do I have left over? 5 times 5, right? Which is 25. Now, you know you can only subtract these if this is the same. So eventually you should get to a root 25 in here, and I would use that to my advantage. Okay, you could divide it by 25 if you wanted, or if that hurts your head, you can do by the 2's. Actually, this one I would probably do by the, I'd probably do 16 times 100. Is that what we did yesterday, or did we do the 2's? Do you guys know that, so because 16 is 4 times 4, it's 2 squared and 2 squared. Do you guys know that that would be 4 2's? Because you can kind of do shortcuts like that. Okay, and then this is 2 and 50, 2 and 25, 5 and 5. So I have 4 2's here, 2 here, so I have 2 to the 6. And then, oh look, I end up with the 2 5's again. So it's the cube root of 2 to the 6, and then the cube root of 25. I just have to simplify this. How many groups of 3 are in 6? 2. So 2 squared is 4. You could also split them up and do it twice if that's easier for you. And then once you have the same root, all you have to do is subtract the numbers in front. So 4 minus 2 is 2. So that's how you get 2 times the cube root of 25. Okay? Alright, and then for 15, 5 goes into itself how many times? 1 time, so 1x comes out. And then 5 goes into 15 how many times? 3. Okay, so those were even, so both of those are going to simplify out. Okay, so we just went over the evaluating absolute value, we did the radicals expressions, And we have some more radicals on the back. Oops, sorry, I should show you right. Okay, so when you're simplifying, remember that if you have two radicals multiplied together, okay, feel free to just combine them to one big radical. When you are multiplying a cubed times a to the 7th, what do you do to the exponents? You add them together. So you have a to the 10th, and then this is just 1b, this is 1b, so it's b squared. Values can only come out if they are larger than what number? The root. Okay, good. So how many times does 5 go into 10? Twice, so that comes out. Nothing can come out here. 5 does not go into 2, so you're going to keep it. Don't forget the little 5th root there, okay? Alright, and then this is one of our special rules. This is in your notes if you want to look back at those examples. But this is a 2. Pay attention up here. So 4 times 2 is going to be 8. This is the 8th root of 256, x to the 8th. Okay, and then 8 goes into itself one time. That's going to go out. And then when you are doing the 8th root of 256, because that is such a big number, I would try 2 first. But you can also do your factor tree. Like you can see I did my factor tree here. I did get 2 to the 8th power. Okay, so 2 comes out. Alright, for 18, when you're simplifying this expression, all you have to do is add the exponents, get a common denominator. Okay? Once you do that, you don't have to go any further. So the common denominator between 2 and 5 is 10. You're going to multiply the top and the bottom of the first one by 5, top and the bottom of the second one by 2. Okay, how is adding the fractions going? LCD is good? Okay. I know, fractions mess people up sometimes. Okay, so for 19, I know that we did some of this together. So this is what I put on the board yesterday. 1/2 is the square root, right? So 64 to the 1/2 is the square root of 64. That's your 8. And then b raised to the 1/2 power, we're going to keep it just like that so that we can multiply it by 2b to the 2/5. Why don't I distribute the 2/5 to the 2 for this one? It's not outside of the parentheses. Okay, so the 2/5 is only on the b here. So all I have to do is multiply number by number to get the 16, and then when you multiply the 2 b's together, you add the exponents. Okay, the questions that you're going to see on your quiz are very similar to the ones that we have on this review. So if there's something that's not clear, please take the time to ask me so we can go over that together, okay? Alright, and then we're going to do number 20 together. Now, I'm going to show you the way I do number 20. Do you have to do them in the same order that I do? No. You can decide what order you would like to do this in. I do recommend, though, you distribute the exponent first, but again, you don't have to. Alright, so let's talk about the goals in problems like this, okay? So what you want to do is you want to condense, let's say condense to one term for each variable. Okay, and plain terms, that means you don't want 2 A's, you don't want 2 B's, you don't want 2 X's. You want one of each letter, okay? What's something else we have to do? No what? Yeah, you don't want to have like the parentheses or a power. So like no powers outside of parentheses. One other thing. What type of exponents don't you want? Yes. So no negative exponents. Okay? So like they said, The order that you do those in is really up to you. I like to start with the no, I don't want the powers on the outside. So I like to do this first. So if I'm distributing, this is a power to a power. If I do a power to a power, what am I doing to those variables? Yes. Okay, so I checked this one off. Okay, the next thing I like to do are the negative exponents. I like to move them and then I go from there, but you don't have to do it that way. So I always say if it's negative, it goes. If it's positive, it stays. So this one's positive. A12 is going to stay. B to the negative 12, negative, so it's got to go. Move it to the bottom, make it positive. X to the negative 6, it's negative, so it's got to go. Move it up, make it positive. Y to the 12 is good. Questions for me on that? And then I do the same thing with the second set. Negative, it's going. Negative, it's going. Positive, it's staying. Positive, it's staying. Oh no, what goes up here? 1. There's nothing left, you can just put a 1 there. Okay? Then from here, I'm going to multiply straight across. So this is the a to the 12th, x to the 6th, and then here when I multiply across, I'm going to do this in order. So I'm going to look for the a first. I'm going to line these up to make my next step easier. Then I'm going to do my b's. When I multiply the b's together, what do I do with the exponents? Add. So b to the 15th, x, I only have one x, right? So x squared, and then what about my y's? So, do you guys agree that when I add these together, it's 12 and 1/3? Okay, now we're going to write it as an improper fraction. How do I do that? 3 times 12 plus 1. 3 times 12 is 36. 36 plus 1, 37. Okay, so now I just have one more step. Well, I have 2 a's, right, and 2 x's. So, to make them into 1, what do I have to do? So, if I divide them, what do I do with the exponents? Yep. So, this is 12 minus 3 over 2. 3 over 2 is just what? 1.5. 12 minus 1.5 is what? 10.5, right? So if I make that into a mixed number, it's just 21 over 2. Is that okay? Now if you want, you can do 12 minus 3 over 2, get the common denominator. This would just be times 2 times 2. 24 minus 3 over 2, 21 over 2. Okay? So it's positive, so where does that go? On the top. And you can tell because 12 is bigger than 3 over 2, so it's going to stay on the top. Okay, the x's, this one is nice and simple. 6 minus 2 is 4, so x to the 4th, b to the 15th on the bottom, y to the 37 over 3. There you go. Okay, so see how if you take it step by step, like it's still a lot to manage, but it's a lot easier if you follow these 3 steps and then do them as you go. And I like to do that one last. Yeah, just take the test. Alright, and then 21. You guys did a great job with this. Honestly, I feel like we did harder ones last year with this one. Right? So what you're asking yourself is, what do you multiply by so that you can not have a radical anymore, okay? So this comes from, do you guys remember rationalizing with the square root? Like if you had 1 over the square root of 3, you'd multiply by root 3 over root 3, right? You guys remember doing that? The reason why this canceled out is because it was 3 squared. And yeah, those cancel. Okay, but now we're doing this with the 9 through the x to the 4th. So if you have 4 x's, how many more do you need to get to 9? 5. Okay, and then what happens is when you do that, on the bottom you end up with the 9th root of x to the 9th, which simplifies to x. And then the top, 1 times the 9th root of x to the 5th, that will stay the same. Okay? I wrote another example down here. You don't have to do that, but if you have like the 9th root of x to the 10th, that one's bigger, right? Do you guys remember how to do that? You just have to go to the next multiple of 9. Yeah, 18. So you need 18. So you multiply by the 9th root of x to the 8th. Okay, and then again, you just ask yourself, how many times is 9 going to 18? 2. So then you have this. Okay? Well, that's something that we talked about on our notes as well. Okay, and then for 22, state whether the polynomial is a monomial, binomial, trinomial, then list its terms, state the degree. So the degree is based on the largest exponent, which is 4. Okay, and then it's a binomial because there's 1, 2 terms. So it can't be the monomials. Okay, and then it says list its terms and then state its degree. So degree is 4. Binomial, those are the 2 terms. That's really all you need for this. Okay. Alright, and then 23. Like 23 is stuff that you did in Algebra 1, right? Doing the distributive property, combining your like terms, linear functions, 6 times x, 6 times negative 3, 7 times x, 7 times 4. Okay, so just pay careful attention to your signs and you should be good. Alright, and then for 24, perform the indicated operations and simplify. You have to FOIL these two. You get t squared plus 12t plus 32. You have to distribute the negative 2 here, combine like terms. Okay, any questions for me on 22 through 24? Alright, and then 25, anything squared, okay, means you multiply these out using FOIL. Can you guys tell me what a common wrong answer you think is for that one? Yeah, not doing FOIL, what do people do? They distribute it. So it would be like 36 plus 64y squared. That is wrong. You have to multiply it out. Okay? And then like I said, I would take that either way, in standard form or reverse standard form. Okay, and then 26, perform the indicated operations and simplify. Now this is to the 3rd power. So when you do that, you have to pick 2 of them in FOIL. I always like to do the back 2 because I like to distribute from the front side there. So FOIL the back, distribute the 3, multiply everything by 3, then multiply everything by negative 2y. This is something based in Algebra 2H. Okay, and then again, I like to line up my like terms from there. Okay, factoring. So 27 is a special factoring equation, the difference of 2 squares. So you have 8x plus 5y, 8x minus 5y. For 28, there are 4 terms. With 4 terms, you factor using what method? Grouping. So you group the first 2, group the second 2, take out the LCD, and then if these 2 match, then you know you've done it right. Okay, so 8x squared minus 5 times 3x minus 1. Why do I have an arrow pointing to the 3? What am I trying to tell you? Anytime you have it to the 3rd power, okay, it is going to be a difference of cubes, okay? So this was 216a cubed minus 125. What you should be asking yourself is what to the 3rd power minus what to the 3rd power. So 125, what number would be to the 3rd power for that? 5. And then 216, you might have to check a few things, but look. You know 2 to the 3rd is 8. You know 3 to the 3rd is 7. 4 to the 3rd is, yeah. 5 to the 3rd, you just did this. So it has to be bigger than 5, right? Right? Because the number is So I would try 6 to the third. 6 times 6 is 36. 36 times 6. You can already see this is shaping up nicely because you have 36 there, and then what do you know? Okay? So this is 6a. From there, you are going to plug it in to your difference of cube formula, which is just like the a minus b, a squared, and then this is always the opposite, multiplied, squared. This first one is positive, a squared, b squared is positive. So those two are positive, and then those are always opposite, okay? So if you put this into factored form, 6a minus 5, and then when you do a squared, 6a times 6a is 36a squared. 6a times 5, 6 times 5 is 30, so it's just 30a. And then 5 squared is 25, okay? If you haven't finished your factoring sheet, the last 3 on there are perfect cubes. Practice them tonight, okay? Because you're going to have it on there, okay? Most of you know how I roll. You know that the reviews look very, very similar to your tests. Okay, now for this one, for this factoring one, when you have 16, think about what your options are, okay? You know that to get to 16, it's either 16 and 1, which is kind of gross, I'm sorry. 8x and 2x, not so bad. 4x and 4x, okay? So we got to start with what we know. And then the negative 45. I make little T-charts so I know what my options are. I either have 1 and 45, 3 and 15, 5 and 9. Did I miss any? Okay. So we know that when we plug these in, we can check them with FOIL. So I just checked a few different ones. Because it's a negative 45, what do we know about the signs? They're opposite. So one has to be plus, one has to be minus, and it should be a negative, middle number. So here I have negative 40. Here I have positive 18. That's actually going to be it, isn't it? Yeah. Okay. I should have looked at this. I tried some other ones first. So once you add them up, just make sure that they go to that negative 22x. Okay? And you might have to try a few. A lot of people like to start with the 4 and the 4, right? So like this is positive 36, this is negative 20, so that's positive 16. That's not what you want. Okay? And then if you plug in those, they would be too big. So don't be afraid to write out your options there. Okay, so we just did the simplifying with exponents, the terms of polynomials, the multiplying the binomials and trinomials, the factoring. Okay, and then what I did is on this, I just picked out ones from your homework. So you've already done these before. You do not have to do them. I'm just telling you, if you got number 20 wrong, okay, or you weren't sure about that, in section 1.2, I picked out a couple questions that were similar to that. Just pick out what you need to practice, okay? Do not do all of these. Do not do all of these, okay? Really, there are some of these that you guys are really good at. Pick out the ones that you got wrong on here, redo some of those. All of the keys will be posted in the 1.1, 1.2, 1.3 homework sections so you can check them. Okay? And then you still have your factoring sheet if you want some factoring practice. I know. So we get out your factoring and let's do a couple of those together.
Okay.